Looking up at the sky on a clear night and seeing the milky band of the Milky Way is like facing a shoreless ocean. Instinct says everything is right there within reach of our eyes. But the truth is we're looking at an architecture of distances so extreme that the mind needs metaphors not to get lost. Today I want to take you on a journey of scale from our blue home to the edge of the observable universe to understand where we fit in this story, and why even tiny as we are part of something grand. Earth, our little blue dot, is about 40,000 kilometers in circumference. For centuries, many people believed it was the center of everything. It was comforting to imagine an infinite world around us. Tailor-made science showed us something else. We live on a finite globe, almost spherical, orbiting a common star on a galactic periphery, immersed in a cosmos that defies any everyday notion of size. Just look at our most famous neighbor to feel that abyss, the moon. From the ground it seems so close you feel like stretching out a hand. Pure illusion. On average, the moon is 384,000 kilometers from Earth. Between us and it, you could fit side by side a little more than 30 Earths or all the planets of the solar system. If we swapped rockets for a car and drove non-stop at 200 km/h, the trip would take about 80 days, almost 3 months, of pure space highway. And to think that in the 1960s and 7S, 3 astronauts crossed that void squeezed into a capsule the size of a compact car surrounded by tubes and cables, with an entire planet rooting for them from here. 12 human beings walked on lunar soil. It's incredible. And even so, we've never gone beyond. So great is it that the Earth-Moon distance seems small when we change units. In cosmic language, it's about 1.28 light seconds the time light takes to make that journey. That helps tune our intuition for the next jump. Mars, that orange speck that has stirred our imagination for decades, is on average approximately 220 million kilometers from us, more than 570 times the distance from Earth to the Moon. On maps, the line between the two looks simple. In practice, it's an orbital dance. The ideal trajectory is elliptical, taking advantage of alignments. Depending on the launch window, the path can stretch out, and the trip in a capsule easily passes 9 months. Meanwhile, message exchanges take 12 to 20 minutes to make the crossing, depending on the planet's relative positions. Emergencies don't allow for instant help, and the crew isolated, confined, subjected to radiation, microgravity, routine, and silence. The feat is epic, and we're still only in the backyard. Climbing the ladder, we reach the dark blue guardian of the solar system, Neptune. The distance from Earth to there ranges between 4.3 and 4.7 billion kilometers. According to the orbital choreography, very few human-made constructions have gone that far. Among them are New Horizons, which continued beyond Pluto and the legendary Voyagers. In 1989, Voyager 2 flew past Neptune and gifted humanity with an intimate portrait of the planet and its moon Triton. Voyager 1, which took another route, didn't pass by Neptune but achieved something even more impressive. It is the human-made object farthest from Earth. Today, Voyager 1 is more than 24 billion kilometers from here, something on the order of 160 astronomical units, with 1 astronomical unit being the average distance between Earth and the Sun. In lunar terms, that's more than 60,000 times the Earth-Moon distance. In Mars, more than 100 times the average path to the red planet. It was this same probe that took the farthest photograph of Earth, the famous pale blue dot. In 1990, already beyond Neptune's orbit and about 6 billion kilometers from home, it looked over its shoulder and captured our world as a bluish glint lost in a sunbeam. Carl Sagan turned that image into a powerful meditation on who we are. Curiously, saying that Voyager 1 has left the solar system depends on the yardstick we use. It crossed the helopause, the border where the solar wind gives way to the interstellar medium, which in a certain sense puts it in the space between the stars. But if we consider the Sun's gravitational domain, whose likely boundary is the Oort cloud, the story changes. Voyager is still at home. The Oort cloud is a shell of comets that may extend for tens of thousands of astronomical units, perhaps even something between approximately 0.8 and approximately 2 light-years from the Sun. To leave this bubble, you'd need to travel about 39 million Earth-Moon distances, or something like 68,000 times the average distance between Earth and Mars. Traveling at 17 kilometers per s like Voyager 1, it would take some 300 years just to reach the inner region of that cloud, and perhaps 30,000 years to cross it. Even on a cosmic scale, and all that is still little, the nearest star, Proxima Centauri, is about 4.2 light-years away. The Alpha Centauri system right next to it is approximately 4.37 light-years away, translating into our lunar yardstick. Reaching Proxima would be like covering around 104 million Earth-Moon distances. If we tried the feat with an Apollo-style spacecraft, flying at speeds close to those used in the 1960s/70s, the trip would last on the order of 100,000 years. Not even the mighty Saturn V was built to launch huge payloads toward interstellar space. It could send almost 50 tons to lunar orbit, but it wouldn't, for instance, put 100 tons on a solar escape trajectory. To touch the stars, we need new ideas. Laser sails, nuclear propulsion, exotic physics concepts. And even then, we're talking centuries, millennia, or engineering still beyond our reach. At this point, it helps to ask, at what distance does the sun stop being visible to the naked eye? Given its absolute magnitude, it would fade out for a human observer, unaided, around 50 to 60 light-years. That's nothing on a galactic scale. It's been over a century since our radio waves began escaping the planet. They form around us a bubble of signals with something like a 120 to 130 light-year radius, 240 to 260 light-year in diameter. It seems like a lot until we remember we live immersed in a cavity of rarefied gas known as the local bubble with something like 300 light-years in diameter. Even within this stellar condo, our sun is already invisible to the naked eye at relatively modest distances. At 10,000 light-year, we enter the neighborhood of the Gold Belt, a ring of star-forming regions about 3,000 light-years across. Our radio bubble becomes statistical dust in the background. At 20,000 light-years, we recognize our address not at the center, not at the edge, but in one of the spiral arms, the Orion Arm, a quiet yet busy neighborhood where we orbit the galactic core. For a long time, the Milky Way was estimated at approximately 100,000 light-years in diameter. Recent observations suggest the full structure may be larger, perhaps nearing 150, 170, or even 200,000 light-year when we account for the faintest domains. Either way, it's a colossal disk, and within it, our sun is just one among hundreds of billions. The stars we can see with the naked eye on perfect nights are a microscopic sample of the whole. Something like a few tens of thousands in a universe with hundreds of billions of luminous pairs of eyes. It's like mistaking a handful of sand for the entire beach. And the Milky Way, for all its grandeur, is still just one among countless galaxies. We're part of the local group, a set with dozens of galaxies led by us and Andromeda with Triangulum, and a host of dwarfs gravitationally bound. The local group in turn is a subgroup of a much larger structure, the so-called Virgo supercluster, a tangle with hundreds of galaxy groups and clusters spread over something like 100 million light-year. This is where we start to see the universe as a web. Galaxies arranged in filaments connecting cosmic cities separated by gigantic voids. But the web doesn't stop there. In 2014, astronomers proposed a new map for our extragalactic neighborhood, Laniakea, immeasurable sky in Hawaiian. It's a vast basin of gravitational attraction about 500 million light-years in diameter that reorganizes our view of the cosmic neighborhood. Lania doesn't contain a 100,000 superclusters, but on the order of 100,000 galaxies, including our Virgo supercluster. And even so, Lania is just a piece of an even larger tapestry, sometimes described by complexes like Pisces Cetus, a network of filaments and clusters stretching for more than 1 billion light-year. Modern catalogs bring together millions of observed galaxies, and everything indicates the universe contains hundreds of billions of them, perhaps more. It's a mosaic in expansion. Speaking of expansion, a word of caution about distances. The oldest light we can detect left about 13.8 billion years ago, but since then, space has stretched. The particle horizon of today's observable universe, the radius out to which we can, in principle, receive information, reaches about 46.5 billion light-year in diameter, approximately 93 billion light-year. And that's only the observable universe. There are good theoretical reasons to suppose the whole is larger, perhaps much larger than the portion we can see. Some inflationary models play with factors of hundreds or more. Whatever the multiplier, the moral is the same. Beyond the horizon there's more universe and more. Faced with this panorama, an inevitable question arises. What are we in here? One galaxy among hundreds of billions, one sun among hundreds of billions of suns, a planet that disappears when you look from just a few light-years away. Are there still those who find it plausible that all this was made for our species alone? Even if we had infinite time, it wouldn't be possible to visit every corner. There will always be incredible worlds we'll never see, regions that will remain forever beyond our causal reach, civilizations that may exist and go extinct without our ever exchanging a single conscious photon. And yet there's a detail that changes everything. In cosmic terms, our presence is a flash. The history of complex life takes up a sliver of time compared to Earth's 4.5 billion years. Human history aside, recorded history, even less. Our technological civilization accounts for a minute fraction, far less than a millionth of the universe's age. But within this instant, we've done something extraordinary. We learned to look. We built instruments that gather faint light for hours, days, years to pull whispers from the dark. We developed theories that connect the dance of distant galaxies to the subatomic particles that make our bones. And we've already sent mechanical messengers that will one day cross the Oort cloud and wander under alien stars. When this instant passes, and it will, nothing truly gets lost. The atoms that make us were forged in the hearts of dead stars. The iron in our blood, the calcium in our teeth, the oxygen in the air, they're memories of ancient explosions. When we're gone, we give it back to the cycle. The universe, which was once almost only hydrogen and helium, has grown more complex over time, and we are an active part of that process. Through life, mind, and culture, the cosmos gains new ways to know itself. It's possible we're rare. It's possible we're not. In both cases, the responsibility is the same. Take good care of our little patch, understand what we can, share what we learn. Maybe the best metaphor isn't to shrink the universe until it fits in a model, but to inflate our sense of belonging until it fits inside it. If you imagine the Earth's undistance as a single step, Proxima Centauri would still be thousands of steps ahead. If each light year fit on a street, the Milky Way would be a vast city-state, Ionia, a continent, and thus a house with a light on along a distant street, small but alive, full of people capable of asking, discovering, inventing. That's why this conversation matters. Because when we measure what separates us from things, we also measure what unites us. It's no small thing that such a fragile species has managed to land spacecraft on the Moon, on Mars, on comets, on Titan, that it has visited all the giant planets with probes, that it keeps eyes orbiting Earth and the Sun to warn us of storms, monitor the climate, and study the physics of the cosmos. It's a beginning. Thank you for watching. Subscribe to the channel and like the video. See you next time.